1.0. Very good. What about for oxygen? If we found its atomic weight and rounded to the nearest tenth,
16.
Just 16.
it would just be 16. Very good, because we have 15.999.
15.98840.
16.0.
So we just round it?
You round to the nearest
Do we
tenth.
have to put the point zero?
What about, question here?
Yes.
Raise your hand. Just trying to get in the habit.
Do you have to put the point zero?
Yes, for these we are putting the point zero for now, because we're showing that we know it's rounded to the nearest 10. Good question.
I have
How about for
another.
CL? Yes, ma'am.
I had a question about the molar mass.
Okay.
I thought the mole was 6.022 times 10 to the 23rd.
Uh-huh. So that is what 1 mole is equal to. It's 6.022 times 10 to the 23rd particles of a substance. Right now we're looking at the molar mass. The molar mass is a little different because it's the weight of 1 mole of these specific atoms. And while this probably, it's because this is all new, guys, so these are some new terms for you guys. It might not all click right now, but once we work through some problems and study these terms more, it should come along. Yes, Chris?
Alright, but, so, 6.02 times 10 to the 23rd is the standard molar mass, right?
It is.
Or one molecule of molar mass.
It's the number of particles in 1 mole. Okay? Number of particles in 1 mole. We're going to do a couple examples such as this that hopefully get this, because it's a very conceptual idea. It's tough, but we're going to master it.
So how does that affect the, wait, does that also determine how many particles in the weight of it?
It deals with it, but right now, what we're looking at, and we're just trust the process in this, we're finding what the molar mass is for these individual elements. So we find that by looking at the periodic table, looking at that value underneath the element symbol, and we know that's our molar mass. Right now, that's what we're doing, and it'll all come together as we start putting the pieces together. But for chlorine, what would be our molar mass rounded to the nearest 10? Anthony?
35.5.
35.5. Very good. So we have these values. These are our molar mass values for these elements. Now, here comes the... Yes, Mr. Stark.
Sorry, guys. It's been a while since I've looked at molar mass. So on that previous slide, Mr. Gasser,
Yes.
if I remember correctly, just to check my own understanding, so that would mean that for 35.5, is it grams or kilograms?
Grams.
So for 35.5 grams of chlorine, if I had that like sitting in my hand, if I counted up the number of atoms of chlorine I had, I would have 1 mole, or the 6 point, I don't remember the number.
022 times 10 to the 23rd.
That's what that would mean?
That's what that would mean. Yes, if you had chlorine, 1 mole of chlorine in your hand, it would weigh 35.5 grams, and you would have 6.02 times 10 to the 23rd atoms of chlorine. So it's this going back and forth between mass in grams and number of particles of that element that I think is kind of what we're seeking to grasp right now.
So what all those have in common, the H, the O, and the Cl, even though they weigh different amounts, they all have the same number of particles that make them up. So if I were to literally sit there and...
Yeah, that's
Thank
what
you
I
so
was
much.
trying to...
That's it.
That was my question, because it's been a while since I've looked at this.
Does that make sense what Mr. Stark
Yeah,
was
that's
talking
what
about?
I'm talking about.
Yeah,
That's it right there.
Yeah, that's...
That for each one of these, there's 6.022 times 10 to the 23rd particles.
Alright. Now I'm with you. Now I'm with you. Good.
You guys good?
Good.
Awesome. All right. Thanks for asking, Mr. Stark.
It's been a while since I've looked at this, so I was trying to bring myself up to date.
That's a good question. So, now that we know how to identify the molar mass of individual elements, we're going to put that together to be able to determine the molar mass of whole compounds. And there's 3 steps to determining this, okay? The first step, and you all can see this on the bottom of your notes, step 1, is we find the molar mass of each individual element in our compound. We're going to use C2H4 as our example, so we'll work through with that. Yes, Teresa?
Oh, I was gonna start it up.
Okay.
I'm gonna try it.
Cool. So for our molar mass for carbon, what would it be, Carissa?
It's gonna be 12, right, yeah.
See, it's going to be
Maybe
12.
24, because two of them
12.0, because we rounded the 10. Sorry, what was that?
would be 24, because it's 2 carbons.
Yes, and we'll get to that. That's going to be the next step. But first, let's make sure we're good on step 1. So hydrogen, we know its molar mass is what, guys?
1.
1.0.
Oh.
So that's what we're doing for this first step. We're identifying the molar mass of each element. Next, we are multiplying each element's molar mass by the number of atoms of that element. Now, if we turn the page and then look at the top, there's not much space underneath number 2. So go ahead and write this number 2 step for our example in that space underneath 3 as well. But real quickly, we're going to multiply each element's molar mass by the number of atoms of that element. And Carissa, I think this is where you were going with your 2. So we have C,
20.
E is equal to 12, H is equal to
Times about 2.
So for this, we look at our subscript of carbon, and we see it's 2. So we know we have 2 atoms of carbon. How many atoms will we have of hydrogen?
4.
4. Good. Okay. So that's our step 2. Lastly, am I good?
We're gonna add.
We're going to add up these values, and what we get will be our molar mass of that compound. So first we do 12 times 2, okay, 1 times 4, and then what do we ultimately get as our molar mass of C2H?
28 grams.
And then our unit for this would be
G/M.
grams per mole.
Oh.
That's how we write that.
Oh, yeah.
But yes, you guys got it. So we're going to do another one together, but before that, are there any questions about this process so far?
Grams per gram per mole.
The steps right now, yeah, we're writing out all these steps just to make sure it gets into everybody's mind as well. So H2CO3. What would be our molar mass of H? 1.0. Very good. And you guys can write this in the bottom part of the notes here where we have this large empty space. Okay, so this is for H2CO3. For hydrogen we have 1.0. What about for carbon? What's its molar mass?
12.0.
And oxygen's is
16.0.
What would we multiply hydrogen by? How many atoms?
2.
Carbon is
1.
Oxygen 3. Very good. And we're going to multiply these values and then ultimately add them up.
What's 16?
And what will we get here, guys?
16 times
48.
48.
And then you would get 0.
62. So we add up all these individual values and get
2
62
gram G over the
grams
mole.
per mole.
Grams
That
per mole.
is the process. Are there any questions about how we go about solving for molar mass of compounds?
I have a question.
Yes, Carissa.
So, what does the answer stand for? There's 62 grams per mole in H2CO3. Is that what it means?
Great question, and this goes back to what Mr. Starr was talking about there and asking. So if we had a mole of H2CO3 in our hand, if we just had a mole in our hand, it would weigh 62 grams
Okay.
in our hand. And that mole would have how many particles of H2CO3? What do you think?
6.022 times 10 to the 23rd.
That's it.
All right.
Guys, go ahead and work on these next 3 in that space below. You can work independently or with partners sitting next to you. We're going to go over these here in a little bit, make sure you guys are all set. All right?
Would be 41, 48.